Okay, ladies and gentlemen, now we know from polynomial world, there's not just multiplying monomials times monomials. You can multiply a monomial by a polynomial. So for example, if you remember, I have in my notes, 4a times 3 plus b. That's the monomial 4a times the binomial 3 plus b. And we know the way you multiply a monomial times any polynomial is to use your distributive property, is to make sure every term inside of the parentheses gets multiplied by that monomial. So we know 4a would get multiplied to 3 and get 12a, and we know 4a would get multiplied to b and give us 4ab. And that's how we got rid of the parentheses. The same is true in radical world. If you have one term of monomial in front of parentheses, side by side connected by multiplication, and inside the parentheses there's many terms, a polynomial, you're going to distribute. Even if there's a radical sign, you're still going to distribute. So if you look at the example, I have square root of 10 times square root of 2 plus 5. On the outside, a square root of 10 is a monomial. It's one term. On the inside, square root of 2 plus 5 is a binomial. That's two terms. And you know inside you can't add them because they're not alike. 5 is a whole number and square root of 2 is not. It's a radical. So we can't add them. So all we can do is distribute. We're going to take that square root of 10 and multiply to each term inside the parentheses. So here we go. We're going to do square root of 10 times square root of 2. Well, both those numbers are inside their radicands. So when you multiply them, the answer is going to be inside the radicand. So square root of 10 times square root of 2 is square root of 20. Then we're going to multiply square root of 10 to a whole number 5. 10 is a radicand. It's inside. 5 is a whole number. It is not inside. So you cannot make square root of 50. The 5 has to stay on the outside. The 10 has to stay on the inside. So square root of 10 times 5 we write as 5 square root 10. Just like you would write 5x. Now the problem is, now that we have these two terms, can we add them? Well, no, they're not alike. You can't add a square root of 20 to a square root of 10. So now you got to see, can I simplify? In square root of 20, is there a perfect square? Yes. In square root of 20, there's the perfect square, 4. So 20 would be written as 4 times 5. We know the square root of 4 is 2. A 2 comes out. We know 5 is not a perfect square, and it's prime, so we leave it inside. So square root of 20 is now 2 square roots of 5. Can we do any simplifying with 5 square roots of 10? Well, 10 is not a perfect square, and 10 does not have a perfect square in it. Do not factor 10 to be 2 and 5. 2 is not a perfect square and 5 is not a perfect square. That's not going to help you. Remember, when we reduce a root, we're looking for perfect squares. There is no perfect square in 10, so 10 stays. So now you have 2 square roots of 5 plus 5 square roots of 10. And I know you want to do more, but you can't. To add, you need like terms. Those radicands are not alike. That's it. That's your expression. It's just like when we did polynomials. No matter how hard, you cannot add an A to a B. Apples plus bananas are apples plus bananas. A plus B is A plus B. In radical world, if you have a square root of 5 and a square root of 10, they're in lowest terms. You cannot add them. They're not alike. All right, let's try an example at the whiteboard.